Okay, so now after determining the size, now we have to determine how the elements are stored, how the elements of A are stored in B, and we have to write the formula for accessing ijth element of A. This is ijth element for accessing ijth element of A. Okay, so this was a bit challenging. First off, I will be considering a 3 cross 3 matrix. So that would be 0, 0 for 0 entry, then 1 comma 1, any entry could be 1 comma 2, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, and this entry will obviously be 0. So I don't know what formula is being used because this would be the first entry of array A, or excuse me, array B. This will be second entry of array B. This will be third, fourth, fifth, sixth, and seventh. So let's see. 1 comma 1 will be the first element of array B. 1 comma 2 will be second element of second B, and I'm just writing all of these down. 1, 2, 3, 4, 5, 6, and 7. So these are all the elements. Excuse me, this will be 1 comma 2, and this will be 1 comma 3. Same here. Okay, now can we find any pattern that is matching? So first off, yeah, I will be storing this array similar to row major order, but not exactly, because these zeros we don't have to store them. So 3 cross 3, I cannot get any idea as to how this array will be stored. So I'll be moving on to 4 cross 4 matrix to get some idea. I've already done the mapping. So let me just copy this. Right, for A and B, 1 comma 3 and 1 comma 4 are first two entries. Then 2 comma 2, 2 comma 3, 2 comma 4 are third, fourth, and fifth entries respectively. 3 comma 1, 3 comma 2, 3 comma 3, 6th, 7th, and 8th entries, and lastly 4 comma 1 and 4 comma 2 are 9th and 10th entries. The zeros are obviously ignored. So let us see if we can see any pattern over here. So in this case, the first two entries are in a separate row. We can see that in the first row and in the last row there are only two entries instead of the three in intermediate rows. For 3 cross 3 matrix also we have similar observation, except the first and the last. Yes, except the first and last row, all the other have three entries. For 5 cross 5 also, which is right over here, first row has 2 entries, last row has 2 entries, and all intermediate rows have 3 entries respectively. So let's see if we can use this observation along with others that we find along the way. So for here, the beginning is 1 comma 3. So this will be for the first row, we can see that pattern that is 1 comma n minus 1 and 1 comma n. These will always be stored in first and second positions respectively. Always stored at one first and second position. Right. So in case n equals to 4, 1 comma 3 and 1 comma 4 are always stored at 1 and 2. And here n equals to 3, so 1 comma 2 and 1 comma 3 are all stored at 1 and 2, which we already found out. So in case the extreme row, first extreme row, so in case of first extreme row, that would be I equals to 1. The arrays stored are as follows. So if I plus j plus n greater than equal to 0 and I plus j plus n less than equal to 2, this was the condition for non-zero entries. Then a I now this we have to think about later. How can we represent 3 and 4 or 2 and 3 in terms of n and j? Because we need to derive a formula. So for formula we have to use these terms. So ai n minus 1, let's suppose, or aij, that will be always stored at 1 and 2. Let's think about this a little. Ai, first of all, let's not write in terms of j, let's write in terms of n. Actually, no. Aij equals to b. Now that would be n minus j plus 1. Is this correct? So for in case a13 equals to b, this should be equal to 0. B, now this will be minus 1. 4 minus 3 minus 1. Actually, we will go, if we go around, this will be decreasing. We still have to think a bit for it. If j increases, so whenever j is increasing, like for 3 it becomes 1, for 4 it becomes 2. Or so if j increases, then the index of b also increases. So this will rather be j minus n, and then add or subtract some value. So j we can derive from here 4 minus 3. That would be, since j here is 3, 3 minus 4 plus 1, 2. And actually that would be b minus 1 plus 2, that would be b1. So this will be b j minus n plus 2 for a13. Let's try for a14 as well. A14, that would be b 4 minus 4 plus 2 equals to b2. Now, for 4 cross 4 matrix, this is satisfied. We also have to check for 3 cross 3 matrix as well, whether this formula holds true or not. So 3 cross 3 matrix, this is over here. I will be copying entire table. Right, again, considering I equals to 1, if I equals to 1 and the same condition, that was I plus j plus n greater than equal to 0 and I plus j plus n less than equal to 2. Then a I j equals to b j minus n plus 1. This is what we found above, plus 2, sorry, b j minus n plus 2. So suppose a1 2, this will be stored at b1. So a12 equals to b 2 minus 3 plus 2 equals to b1. All right, and a1 comma 3 or a13 equals to b 3 minus 3 plus 2 equals to b2. All right, so for I equals to 1, for one extreme case, we have got a condition, it is satisfied for 3 cross 3 and 4 cross 4. So by this, I can assume that Aij, that this condition will hold true for all the matrices. In case of I equals to 1, our question is still remaining. We only found for the first row, but then the non-zero entries are not only the first row, they are second, third, fourth, and then in the last row as well. Now, first of all, I would like to begin with the last row in mind. First, let's finish the extreme cases. So again, for 3 cross 3, n equals to 3, correct? Now, if we consider these cases, 3, 1, 3, 2. So 3, 1, that's 2 over 6, 3, 2, that is 2 over 7. For 4 cross 4 matrix, let us copy this again. Okay, so let's remove these as well. So 4, 1, 4, 2. 4, 1 is stored at 9th position, 4, 2 is stored at 10th position. Now in extreme case, you are noticing j is always 1 and 2, right? So for 4, only 4, 1, 4, 2. So j here equals to 1, j here equals to 2. For 3 cross 3 matrix, j equals to 1, j equals to 2. For 5 cross 5 matrix, again here, let's use yellow, j equals to 1 over here, and here also j equals to 2. So if I equals to n, one thing we have obtained is if I equals to n, then j equals to 1 or j equals to 2. This has to happen for every matrix. Now if to derive the formula and the other condition, I plus j plus n greater than 0 and I plus j plus n less than equal to 2. So here we have to derive the formula for a I j. What will be this? Now that would be, in this case, we will be considering the total number of elements stored, right? That was 3n minus 2 because we are beginning from the end in mind. This is 3n minus 2 for 4. So that we 4 times 3, 12 minus 2 equals to 10. This is the last index of last element, that would be 10. beginning index is with 1, and so ending will be at 10. For 3 cross 3 matrix, ending will be at, let's check, ending will be at 7. Yes, here ending will be at 7 for 3 cross 3 matrix. So in this, only I is changing, only j is changing, I is constant. So aij equals to 3n minus 2, and then we could be adding j, I believe, or subtract it from it. So like last one should be equal to 3n minus 2. Second last should be equal to 3n minus 2 minus 1. So this could be plus j minus 1. If we look carefully, why I'm assuming j minus 1? I'm assuming j has to be positive, because as j increases, with that the index in A or in B also increases. So j has to be positive to counter the effect of j to obtain the value that I desire. So like A41 equals to 10, 3 minus 2 in this case would be 10, plus 1 minus 1. No, this should actually be equal to 9. This will be 2 instead then. So 10 plus 1 minus 2 equals to 9. And then A4 2 equals to 10 plus 1 minus 10 plus 2 minus 2 equals to 10. So j has to be positive, because as j increases, with that index also increases to counter the effect of j so that I can get the desired value. This was a little bit of try and error, but not to a large extent. Like this could be performed. So for aij, when I equals to n, j will be equal to 1 or 2. So aij will be stored at b, 3n minus 2 plus j minus 2. That will be equal to b, 3n plus j minus 4. We can check this. So for A41, A41 is stored at B. 12 plus, we are using this formula, 12 plus 1 minus 4 equals to B. 12 plus 1 is 13, 13 minus 4 is 9. So yeah, that's good. A42 will be stored at B. 12 plus 2 minus 4, that would be 12 minus 2, so that would be B10. For A4, this is satisfied. Let's check for A3 as well now. A3, all right, it's over here. I'm going to copy this as well. So for A3, 3 cross 3 matrix, A3 1 equals to B, 3n plus j minus 4 equal to B. 3 times 3 is 9, j is 1 minus 4 equals to B. 10 minus 4, that is equal to 6. So yeah, A31 is stored at 6. We is correct on this formula. A32 equals to B. 3n plus j minus 4 equals to B. 9 plus 2 minus 4 equals to B7. 9 plus 2 is 11, 11 minus 4 is 7. So that is also correct. So for another extreme value, this comes out to be correct. Aij equals to B. 3n plus j minus 4. And this we have checked, and if it's correct in two matrices, then I'm believing it will be correct in all of the matrices of the given sort. With that being done, now we have to proceed to the intermediate matrices. For that, let's check. Again, taking 3 cross 3 as an example, and then 4 cross 4 as well as an example. So for 3 cross 3, except one, 3 cross 3 doesn't really give an idea as to how these elements will be stored. Let's remove the thing outside. For 3 cross 3, I'm not getting considerable idea. So I will be going with 4 cross 4 matrix. So I can get an exceptionally good idea. Here's 4 cross 4. Copying it. Or we need some more space. Alright, so for 4 cross 4, we can see that after the first one, the row tends to shift towards left. Right, so first it was here, then it was here. We can also see that with 5 cross 5, right, it shifts towards left. All the three elements, they keep shifting towards left. So this, then it shifted one value to the left. So we see these values, then shifted value to the left, then we receive these values. So we can say as we go down, as we go further, as I increases, the index of I begins with one lower value. So for yes, for 1 is less than I is less than n, the value of I begins with lower value. Actually, that would be j. The value of j begins with lower value than the previous row. So for suppose 2, 3, 4. So if I equals to 2, then it begins with, then j will hold the value of n, n minus 1 and n minus 2. If I begins from 3, then j begins from n minus 1, n minus 2 and n minus 3. And that's pretty much it. So can we derive a formula from here to see how the elements are stored? So first of all, we can see that as I increases, the index also increases. As j increases, the index also increases. But with I and j, there is some sort of difference. Now we cannot use the direct formulas that we use for extreme cases because these are shifting leftward. We also have to account for that. So let us think for a minute. I equals to 2, j equals to n. So at 2 comma n, if a is 2 comma n, b would be 3. 2 comma n minus 1, b would be 4, 2 comma n minus 2, b would be 5. So first of all, I will not write j in terms of n, I will write j in terms of I. Let j, if I can incorporate I over here as well, so j will be n minus I, let us suppose plus 2. No, that won't help us in any way. 2, 3, 4, 1, 2, 3. For 2 comma n we got 3. For 3 comma n minus 1 we got 6. It is not helping. I believe I have to cut this video and then get back with the another one, so that all this time is not wasted with me just thinking out loud.